This chapter, Electrochemistry, is about two things. First, how a chemical reaction can be used to make electricity. And second, the reverse, how electricity can be used to drive a reaction. To understand all of this, we first need some basic ideas: what an atom is, what an ion is, what a compound is, and how electrons are handed from one to another. This video is about those foundations. Let us start from the very bottom. Everything around us is made of extremely tiny particles, and these tiny particles are called atoms. A solid metal, the atoms are packed tightly together, hooked inside one atom. But its center is the nucleus, which holds two kinds of particle, protons and neutrons. A proton has a positive charge, while a neutron has no charge at all. Moving around the nucleus are very tiny particles called electrons, and each electron has a negative charge. In an ordinary atom, the number of protons equals the number of electrons. Both the positive and the negative charges are equal, and they cancel each other out. The atom has no overall charge, and we call it a neutral atom. Now suppose an atom sheds one electron. It then has one extra positive charge, so it becomes a positive ion. And if an atom catches an extra electron, it gains one extra negative charge, so it becomes a negative ion. In short, an ion is simply a charged atom. Here is the most important idea. A shed electron never just vanishes. Another atom is always there to catch it, so shedding and catching are really one paired handover. Take sodium and chlorine. Sodium sheds one electron and becomes the sodium ion, which is positive. Chlorine catches that very electron and becomes the chloride ion, which is negative. Shedding electrons is called oxidation, so here sodium is oxidized. Catching electrons is called reduction, so here chlorine is reduced. Because the two always happen together, this pair is called a redox reaction. Now see what these two ions do. The sodium ion is positive and the chloride ion is negative. Opposite charges attract, so the two ions lock together to form sodium chloride, the common salt we use every day. A compound is what forms when ions lock together. Many compounds form this way. For example, the copper ion, that is copper 2+, locks with a negative sulfate ion to give copper sulfate. In the same way, the zinc ion locks with sulfate to give zinc sulfate. A compound is really a store of ions, with the ions hidden inside it. How easily a metal sheds an electron is called its reactivity. To pull an outer electron away from a metal, you need a push. For some metals a small push is enough, while others need a big push. Zinc sheds an electron with only a slight push, so zinc is more reactive. Copper sheds an electron only when given a strong push, so copper is less reactive, and that is why copper is mostly found locked inside compounds like copper sulfate as an ion. Let us quickly recap the foundations. An atom has protons, neutrons and electrons, and an ordinary atom is neutral. When an atom sheds or catches an electron, it gains a charge, and that is an ion. Opposite ions lock together to form compounds, and reactivity is how easily a metal sheds electrons. Thanks for watching. Like and subscribe to Baidyati. Electrochemistry, last 12 chemistry in English.